In this video, I'm going to focus on the photoelectric effects question. The work function of potassium is 3.20 times 10 to the power minus 19 joule. Calculate its threshold frequency. So the work function is the minimum amount of energy needed to eject an electron from the metal surface. And we usually show it with phi or sometimes with W. And it's equals 3.20 times 10 to the power minus 19 joule. Calculate its threshold frequency. Threshold frequency, we also show it with F naught. And it's the certain frequency of light below which no photoelectron are released from a metal. So if we want to release electron from a metal, we need to use a light with frequency larger than F naught. Right now, we have the work function, that is energy, and we know that H is usually given to us, that is Planck constant, is 6.626 times 10 to the power of minus 34 joule. And we need to find frequency. The formula that we have between energy and frequency is this formula. And also I can write it like phi equal h f naught. By substituting work function for phi 3.2 times 10 to the power of minus 19, and h is 6.626 times 10 to the power minus 34, we can find our F naught. So as a result, F naught is equal to 3.2 times 10 to the power minus 19 divided by 6.626 times 10 to the power of minus 34, and it's equal to 4.83 times 10 to the power of 14 hertz. So this is the minimum energy that we need in order to release one electron from this metal, and this is the minimum frequency of light that we need. Okay. If a light with frequency of 7.50 times 10 to the power 14 hertz is shone onto the potassium surface, calculate the maximum kinetic energy of its photoelectron. So right now we see the frequency of light that we are using, this F, actually is larger than F naught. And we know the law of conservation of energy. So we are giving HF, this is the total energy of light that we are giving, a photon of light, and part of this energy is used to release the electron, that is work function, and the leftover actually is as kinetic energy of that electron, that we name it photoelectron. So just if I put K max as subject, it means K max, maximum kinetic energy, is equal HF minus phi. Okay, right now, calculate the maximum kinetic energy. The only thing that we need to do now, just substituting number. Okay, K max equal H, that we know is 6.626 times 10 to the power of minus 34. F is given to us, that is 7.50 times 10 to the power of 14, and work function also given to us, that is in part A, it was 3.20 times 10 to the power of minus 19. As a result, K max become equal to 1.77 times 10 to the power of minus 19 joule. Okay. So we have our K max. Right now, the second part, it said calculate the speed of the photoelectron. It means maximum speed, actually, maximum speed. So for answering this part, so we know the formula for kinetic energy is half mv squared. So just I have the maximum kinetic energy because it's maximum. So definitely I get maximum V. Maximum, just I substitute number 1.77 times 10 to the power minus 19. That is maximum kinetic energy. Sorry. Equal half. And here, something that's moving is electrons. So we need mass of electron that usually it's given to you. You don't need to be worried about mass of electron. That is equal 9.109 times 10 to the power of minus 31 kilogram. Okay, just I put mass of electrons here for M. So it's 109 point, sorry, I forgot the 9 here. Just I rub it. So just I put mass of electron 9.109 times 10 to the power minus 31 and then V squared. If you put it in your calculator, you see V equal 6.23 times 10 to the power of 5 meter per second. Okay. The last part of question is calculate the stopping voltage. Okay, so what's the stopping voltage? If I have a circuit with two plates that I want to name it plate A and plate B, and then this circuit is attached to variable voltage source. And if I show it like this, okay. And let's say A is potassium. And then if I shine a light on potassium, that the frequency of this light is bigger than F naught, something that happens is it start releasing electron. And if this plate is positive, that is attached to positive terminal. So electron accelerate towards the positive plate, that is plate B. But if I apply a negative voltage to plate B, for example, instead of this positive, if plate B is negative, so if I put it negative, something that happens, this plate B actually repel electrons. So electron ejected from plate A repelled by the plate B. If we increase the applied voltage, the repulsion force also increases. And if the voltage, applied voltage, is high enough to stop the photoelectron, then this applied voltage, we name it stopping voltage, and we show it with V naught. So V naught actually is the voltage that we need to apply to this plate in order to stop electrons. Right now, we have a formula. The Ke, kinetic energy of photoelectron, actually is equal to charge of electron times V naught. So if I name this one stopping voltage, this one is charge of electron, that is equal to 1.6 times 10 to the power minus 19 coulomb, that for electron is negative, then and these two, if you multiply, that is equal the kinetic energy of electron. Right, now let's see if we can find stopping voltage. So we calculated our K in the first part of the question, and it was equal 1.77 times 10 to the power of minus 19. We know charge of electron 1.6 times 10 to the power minus 19, so we can find our V naught. So as a result, V naught equal 1.77 times 10 to the power minus 19 divided by 1.6 times 10 to the power minus 19. That is equal 1.11 volt. So if you apply this voltage, 1.11 to plate B, negative voltage to plate B, as a result, so it can stop electron that is ejected from plate A.